Hello everyone, this is Ashish and welcome to Infinity Learn JEE YouTube channel. So in this particular session today I would be talking about the limits, the 7 indeterminate forms, how do we find out the answers in each of these forms, what are the different PYQs that has been asked in so many years, right? So I have accumulated everything in this concise one session on limits that starts right now. Right. So before we move on, I just try to understand that how many days are left and what are the things which are essential in the coming week. So in the last 1 week, right, the last lap of your preparation before you write JEE Main exam, the most important thing is that in the last 7 days, pick up the different exams paper that has happened in 2019, 20 and 21. Right, let's say you pick any random 8 papers, 8 actual JEE main papers, right, and you attempt them in a 3-hour format. जैसे अपना एक मेंस का एग्जाम होता है, सिमिलरली वैसे ही तुम्हें एक घर में अपना एनवायरनमेंट बना के, राइट, फोन वोन लैपटॉप सब साइड में रख दो अभी, राइट, नेक्स्ट 8-10 डेज के लिए, स्पेशली उन 3 घंटे के लिए. ऐसा ना हो एग्जाम में क्वेश्चन सॉल्व कर रहे हो, फिर इसका पेपर है, राइट, और साथ में इंस्टाग्राम का नोटिफिकेशन भी आ रहा है. So keep your phones, everything aside, right? 3 hours, let's say if I'm writing a test at 9:30 a.m. So 9:30 to 12:30, I would be writing one JEE main actual paper of the last 2019, 20 or 21, any paper that you can pick. अगले 8 दिन हर दिन एक पेपर लिखो, उस पेपर का एनालिसिस करो, राइट? ट्रस्ट मी, बहुत ज़्यादा फ़ायदा हो जाएगा तुम्हारे रैंक में, तुम्हारे स्कोर में, तुम्हारे कॉन्फिडेंस में, इफ़ यू डू दिस थिंग for the next 7-8 days, right? Constantly, every day without missing even a single day. अगर बुखार आ रहा है, तबीयत खराब है, पेट दर्द हो रहा है, टांग में दर्द है, still make sure you write that particular test. उसके अलावा चाहे तुम दिन भर में कुछ मत करो, आराम करो, लेकिन वो 3 घंटे का टेस्ट उस दिन होना ही होना चाहिए, right? So with that thought, we would be starting this particular workshop. So हमेशा की जैसे सबसे पहले हमें करना क्या है? हमें करना है सब्सक्राइब एंड लाइक. अगर कर चुके हो, बेल आइकन पे क्लिक कर चुके हो, कुछ नहीं, शेयर करो अपने फ्रेंड्स में, फैमिलीज में, राइट? नाउ द IEL मास्टर क्लासेस as I have been telling you so far in every workshop, right, the best feature of these master classes are they are free, they are absolutely free, right? You don't have to pay anything for these classes, and in these classes India's top educators, teachers would be there. और हर मास्टर क्लास में हम लोग क्या करते हैं, हम एक कंसेप्ट को पिक करते हैं, राइट? एक कंसेप्ट, और उस कंसेप्ट का राइट फ्रॉम द बेस टिल द हाईएस्ट लेवल वी डिस्कस, पूरे के पूरे उस कंसेप्ट का पोस्टमार्टम किया जाता है उस पर्टिकुलर मास्टर क्लास में. अगर मैं सिंपल वर्ड्स में समझाऊँ तो अगर तुम्हें किसी भी कंसेप्ट में दिक्कत है, राइट, अटेंड दोज मास्टर क्लासेस. दे हैपन फॉर फिजिक्स, केमिस्ट्री एंड मैथ्स, ऑल 3 ऑफ देम, राइट? नाउ अगर तुम्हें ये करना है तो उसके लिए तुम्हें हमारी वेबसाइट पे जाना पड़ेगा, दैट इज www.infinitylearn.com, बिकॉज ये मास्टर क्लासेस वहाँ पे होती हैं. जो अभी तुम देख रहे हो, दिस इज अ यूट्यूब सेशन. मास्टर क्लासेस हैपन्स ऑन दी वेबसाइट. वहाँ जाओ, जितनी तुम्हें मास्टर क्लास करनी है, 1, 2, 50, 100, राइट, यू कैन अटेंड ऑल दोज मास्टर क्लासेस. दे आर कंप्लीटली एंड एब्सोल्युटली फ्री. अपार्ट फ्रॉम द कंसेप्ट, देन यू हैव दी टेस्ट सीरीज. 2 मॉक टेस्ट है, 12 पिछले साल के JEE के पेपर्स है. जैसा मैं अभी बोल रहा था कि तुम्हें अगले 8-10 दिन में JEE मेन के एक्चुअल पेपर्स लगाने हैं. सो व्हाई नॉट यू गो ओवर देयर ऑन द वेबसाइट, राइट, रजिस्टर योरसेल्फ एंड राइट दोज फ्री मॉक टेस्ट, राइट? तो तुम्हें वो पूरा का पूरा अपना 9:30 से 12:30 या फिर जो भी तुम टाइम में लिख रहे हो, वो 3 घंटे का टेस्ट तुम वहाँ पे भी लिख सकते हो, राइट? दैट इज योर चॉइस. सो नाउ विल मूव ऑन टू दी, आज का कलर ब्लू लेते हैं पहले, राइट, फिर चेंज करेंगे, राइट? विल स्टार्ट विद द ब्लू कलर फर्स्ट. सो let us start solving the limits के questions. Now limits के we all know there are 7 indeterminate forms, right, which is 0 by 0, infinity by infinity, infinity minus infinity, 1 raised to power infinity, right, 0 into infinity, और infinity raised to power 0 और 0 raised to power 0. अब इन indeterminate forms में ना बहुत सारे types के questions बन जाते हैं, right? JEE में अगर question आता है तो एक चीज़ हमें पता है कि he will not be asking me to show the steps. Only the answer is important. So the first kind of a trick that I will give you, whenever you see a box, fraction, right, modulus function, signum function, if you see such kind of expression in the question of in the question of limits, कौन कौन से box मतलब greatest integer function, fractional part, signum function, modulus function. In those questions, always follow left hand limit and right hand limit. So calculate the left hand limit, calculate the right hand limit separately. That is the first thing. Second, right, if you see a 0 by 0 or infinity by infinity form, then you can always use L'Hopital. What is the L'Hopital rule says? Differentiate the numerator, differentiate the denominator and find out the limit. If you once again get 0 by 0 or infinity by infinity, do the derivative once again. Right, keep on doing it unless and until that question gives you an answer. Now 0 into infinity form is also similar to 0 by 0 or infinity by infinity. Whenever it is a 0 into infinity form, pick that infinity term, take it to the denominator. For example, if there is a in the numerator, so I can write 1 by a in the denominator. They are mathematically the same expression. So 0 into infinity, I can take that infinity term and I can write that infinity term in the denominator as 1 by infinity. This will turn the expression into 0 by 0 form. Or if you want, you can take the 0 wala term, take it to the denominator. So you will have infinity upon 1 upon 0, which will become infinity by infinity. So once again, I can use the L'Hopital rule. So 3 forms are done. Fourth form is infinity minus infinity. Whenever you see infinity minus infinity, now you think logically, if I remove infinity from infinity, I cannot say what will be my final value. So it's an indeterminate form. In such questions, whenever you find infinity minus infinity, you always take the LCM, right? Because infinity minus infinity. So there are two terms. So take the LCM, combine them together, simplify them. Infinity minus infinity upon simplification will give you either 0 by 0 or infinity by infinity. So our job would be done and then we can use the L'Hopital rule over there. So this is how we solve infinity minus infinity. For 1 raised to power infinity, right, infinity raised to power 0 or 0 raised to power 0, yeah. So all these 3 forms can be solved by taking the log on both the sides, right. Once you take the log and you rearrange the terms, every term of these 3 cases will become either 0 by 0 or infinity by infinity. So whenever you see 1 raised to power infinity, 0 raised to power 0, infinity raised to power 0 form, always take log on both the sides, and once you take the log, remember your question will be converted into one of your favorite forms, which is 0 by 0 or infinity by infinity. Once again, we can apply the L'Hopital rule over there, right? For 1 raised to power infinity, I will also help you out with one more trick to find out the answer that we'll discuss while I would be solving the problems on 1 raised to power infinity. So this is how, remember all these points, whatever I have said right now. Trust me, whatever question comes in JEE Main or Advanced, these tricks can easily solve and make you comfortable and confident inside the examination hall. 17 साल से पढ़ा रहा हूँ, आई हैव नेवर सीन इवन अ सिंगल प्रॉब्लम जो इन ट्रिक्स एंड ट्रिप्स से सॉल्व नहीं होती है. इसके अलावा जो कुछ भी लिमिट्स के चैप्टर में है सब एक्स्ट्रा है. आई बात समझ में? सो नाउ विल मूव ऑन टू द क्वेश्चन नंबर 1 गाइस. So question number 1 says f is r to r be a continuous function, then limit x tending to pi by 4. I have to find the limit of this particular function. Question has been asked in 2021, right? Now let us observe. If I put x is equal to pi by 4 in the expression, right? Now that is the first step. Whenever you see a question on limit, the first thing we do is we put x as pi by 4 or x as a in the expression, because then only we would be able to know whether it's 0 by 0, infinity by infinity or whatever. So if I put pi by 4, what is sec pi by 4? Sec pi by 4 becomes root 2. Root 2 whole square becomes 2. So I am integrating this function from 2 to 2. So no matter what fx is, if I integrate any function from a to a, my answer will always be 0. So this numerator is tending to 0. If I put pi by 4 over here, it becomes pi by 4 whole square, which is pi square by 16 minus pi square by 16. This is also going from to 0. So I can say this limit is nothing but 0 by 0 form. And right, so now everybody knows if it's 0 by 0, we will use the L'Hopital rule and nothing else. Right, so we'll be using L'Hopital rule. Right, now इस नाम के बहुत सारे प्रोनाउंसिएशन है, राइट. कुछ लोग L'Hopital बोलते हैं जो मेरे जैसे है, कुछ लोग L'Hopitals बोलते हैं, राइट, हॉस्पिटल्स बोलते हैं, राइट. अलग अलग नाम है. आप लोगों को क्या क्या मतलब नाम से, कंसेप्ट हमें पता है. सो अभी मैं क्या करूंगा, देखो यहाँ पे मैं डिफरेंशिएट करूंगा. सो नाउ यू डिफरेंशिएट द न्यूमरेटर एंड डिनोमिनेटर separately. No p by q formula. Differentiate the numerator and differentiate the denominator separately. What is the numerator? Pi by 4 is a constant, so I will write pi by 4. Derivative of integral, right? So how do we differentiate the integral, right? Upper limit goes into the function, so upper limit goes into the function. Then the derivative of the upper limit, what is the derivative of the upper limit? 2 sec x into sec x tan x, right? Minus lower limit into the function into derivative of lower limit. Now I am not writing that particular term because lower limit is a constant, and if I differentiate the constant with respect to x, my answer would be 0. So I am not writing the second term over there because it is 0. So how do we differentiate an integral whose limits are the function of x, right? Replace x by the upper limit into the derivative of upper limit minus replace x by lower limit into derivative of the lower limit. This is also known as Leibniz rule, right? When we will be talking about definite integration, we would be discussing this rule over there. So now I have the numerator. What is the denominator? X squared. Derivative of x squared is 2x minus pi squared by 16. Once again a constant, so derivative is 0. So now x tending to pi by 4. Let's put pi by 4. So this is pi by 4 into f of 2, right? This would be a root 2 whole square into 2 sec square x. Once again 2 tan of pi by 4 1 upon what is 2x, 2 into pi by 4, right? So pi by 4 gets out with 2, this 2 gets out with this 2, so my answer is 2f2, right? Now the question says I have to find out the answer. Answer is option number B, right? So now you guys can see this question of limits, right? Nothing, देखने में कैसा अजीब सा लग रहा है, but मेरे को करना क्या है यहाँ पे L'Hopital लगाना, because the question was 0 by 0 form, right? और let's say जिन बच्चों को नहीं पता है, मैं न्यूटन लेबनिट्ज थ्योरम एक बार यहाँ पे लिख देता हूँ, right? ताकि तुम्हें याद रहेगा मैंने यहाँ पे क्या किया है. So this is called as Newton-Leibniz rule. So it says if your h of x, right, is some integral, let's say fx to gx rt dt, then if I have to find out the h dash x. Now first try to understand this. If I integrate this, I will get an expression in terms of t, but the upper limit are in x. So when I put the upper limit, right, and the lower limit, the function becomes a function in x. So how do I differentiate h dash x? Replace upper limit in the function. So r of, instead of t, I will write gx into derivative of gx, derivative of upper limit, minus lower limit into the function into derivative of the lower limit. This will be equal to the h dash x. The same expression I have used over here to differentiate this expression. The second part becomes 0 because f dash x would be 0 in that particular case, right? So now we can move on to the example number 2. So what is the example number 2? Alpha and beta are two distinct terms. This kind of a question has been asked in 2021 as well as in earlier PYQs as well, right? So alpha and beta are the roots of this quadratic equation. So from this I can conclude that the root will always satisfy the equation. So x square plus bx plus c is equal to 0. So I can say that x minus alpha into x minus beta is equal to 0 is nothing but the same expression, right? Or you can say alpha and beta will satisfy this equation. So alpha square plus b alpha plus c is equal to 0 and beta square plus b beta plus c is equal to 0, right? Now ये भी बोल सकते हैं, ये भी बोल सकते हैं. यहाँ पे coefficient of x square is 1, यहाँ पे भी coefficient of x square is 1. If there would have been some other coefficient, I would have multiplied this by that particular number over there. So now look at the limit. Now if I put x to beta in this particular case, this becomes beta square plus b beta plus c. Beta square plus b beta plus c is 0. So it becomes e raised to power 0, which is 1. 1 minus 1 is 0. This is already 0. The numerator is 0. Denominator, if I put beta, it is 0. So it is once again 0 by 0. So if it is 0 by 0, I will once again use the L'Hopital rule and I will differentiate the numerator and the denominator. Let us differentiate the numerator and denominator. So if I differentiate, now differentiate carefully, right? Do not make a mistake in the derivative, right? Because the question, the approach is pretty simple. But if you do a mistake in finding out the derivative, right, we'll end up with a wrong answer. And with a wrong answer, instead of getting a +4, we'll get a -1. So e raised to power something, derivative is e raised to power something into derivative of something, that is 2x plus b. -1, derivative is 0, -2, x square plus bx, the derivative is 2x plus b upon 2 into x minus beta. Now see, if I put x minus beta, denominator becomes 0, right? If I put in the numerator x is equal to beta, this becomes 0, e raised to power 0 becomes 1, so this becomes 1 into this, so this term would be 2 into 2x plus b, this is also 2 into 2x plus b with a minus sign, so numerator becomes 0, denominator becomes 0. So after using L'Hopital, I am still getting 0 by 0. So what will we do? The next step is, right, reiterate the process, repeat L'Hopital rule once again, right? And that's the beauty of L'Hopital. Unless and until this will give me the answer, I will keep on using L'Hopital, right? ये भी stubborn है तो हम भी जिद्दी हैं, हम भी तब तक करते रहेंगे जब तक आंसर निकाल के नहीं देगा. Now differentiate this. So numerator derivative is 2, that's it, and nothing else. Now I will differentiate the numerator. So numerator, this is a product rule, right? So now we'll differentiate e raised to power something into derivative of something would be 2 into 2x plus b. So I will have 4 into 2x plus b whole square plus e raised to power 2 into x square plus bx plus c. Now I will differentiate this. The derivative of this is 2 into 2 minus derivative of this is 2 into 2, 4. Now you put x is equal to beta. So x is beta, this becomes 0, right? So e raised to power 0 is 1. So this is 1 into 4. So this is 4. 2 beta plus 2. 2 beta plus b whole square plus e raised to power 0 is 0. This becomes 4. 4 minus 4 is 0. So I'll have a 0 over there upon 2. So we got 2 into 2 beta plus b whole square. This is my answer. And do we see this in the expression? No, we don't see, right? The answers are in form of b and c. My answer is form of b and beta. I have to remove beta from here, right? So now 2 beta plus b I know, right? Okay, so 2 beta plus b, and we have to remove b and c. Okay, got it. So I'll find out beta from here. So what is the beta? Beta is minus b plus minus under root d upon 4a, sorry, upon 2a, right? Minus b plus minus root d upon 2a. Now a is 1, so beta is equal to, what is b? B is b plus minus, this would be b square minus 4c upon 2. Multiply this, you get 2 beta plus b is equal to nothing but plus minus b square minus 4c. So I got the value of 2 beta plus b. Now replace 2 beta plus b over here. So this becomes 2 into plus minus under root of b square minus 4ac. If I square, the under root sign will remove and I will have 2 into b square minus 4c. So if you look among the options, option number C is your correct answer, right? So whenever a quadratic is given and whose roots are also known, right? Either I can write this or I can write this or I can write down the formula itself, right? Using the Sridhar Acharya method, which is root of any quadratic is minus b plus minus root d upon 2a. Right, so this is clear. We can move on to the next one. Now let us try the next example. Now what is the next example? Limit x tending to infinity, right? क्या बोल रहा है क्वेश्चन? लिमिट x टेंडिंग टू इन्फिनिटी है, यहाँ पे डालते हैं x स्क्वायर माइनस x प्लस 1 minus ax. This is given as b. So if I put x is equal to infinity, this becomes infinity square minus infinity plus 1. Simplification will give me infinity. Root of infinity is infinity. This is infinity, this is minus infinity. So I have infinity minus infinity form. And remember what did I told you? Infinity minus infinity form, we have to simplify it, and we have to simplify it so that it becomes 0 by 0 or infinity by infinity form. So I have to simplify this. Now how can I simplify this? These are the terms. I cannot take the LCM because there are no denominators over here. But I can see root of something minus something, right? So I can rationalize this. So let me rationalize because I have to simplify this. So I am rationalizing this. So for rationalization, we multiply with the conjugate, right? Or, right, if you remember limit x tending to infinity, we should have infinity by infinity form. So I should have a denominator. So there is only a numerator. So I should need a denominator. That's how, right, we came to know that I can rationalize. So either of the logic, both of them will say you have to rationalize this. So if I rationalize this, what do I get? Limit x tending to infinity. Look at the numerator, right? This is a minus b, a plus b. So I'll get a square minus b square. So square of this minus square of this. So from here I'll get x square minus x plus 1 minus a square x square. And what is there in the denominator? This term x square minus x plus 1 plus ax. Let us simplify this. So this is limit x tending to infinity. This becomes 1 minus a square into x square minus x plus 1 upon under root of x square minus x plus 1 plus ax. Right? So now if I put x tending to infinity, this becomes infinity by infinity form, right? Now in infinity by infinity form, I can use the L'Hopital, or if you remember, right, we used to take x raised to the power common, where power is the maximum power of x, right? So now over here, if you compare, right, denominator is a linear expression, right? This term is 1 degree. I have x square, but I have a under root, right? So this becomes a linear. Over here, I have a quadratic. So if I have infinity by infinity form and the numerator is quadratic, right, and the denominator is linear, or in other words, denominator is a lower power as compared to the numerator. So the answer for this limit will always be infinity, right? If denominator has a higher power and numerator has a lower power, then your answer will always be 0. If numerator and denominator has equal powers, then only you will get a finite value. Now look in the question. This is given as b, right? So I am getting a finite value, which means that the degree of the polynomials in the numerator and denominator needs to be the same. तो नीचे लीनियर है, ऊपर क्वाड्रेटिक है. अब मैं लीनियर को तो क्वाड्रेटिक नहीं बना सकता, लेकिन क्वाड्रेटिक को मैं लीनियर बना सकता हूँ. कैसे? जो एक्स स्क्वायर का टर्म है, जो कोएफिशिएंट है, वो जीरो कर दो. अगर ये जीरो हो जाएगा तो एक्स स्क्वायर गायब हो जाएगा ना. अगर एक्स स्क्वायर गायब हो गया तो मेरे पास न्यूमरेटर में भी लीनियर है, नीचे भी लीनियर है, आंसर आ जाएगा. तो यहाँ से मैं क्या बोल सकता हूँ? ए स्क्वायर माइनस 1 को जीरो कर दो तो ए कितना हो जाएगा? प्लस माइनस 1. सो दिस आई गॉट फॉर ए. सो अभी ए स्क्वायर माइनस 1 को मैंने जीरो किया तो ये जीरो हो गया ना गाइज. Zero into anything is zero. So now there is no such term over here. So I have only linear and a linear. Now you differentiate, right? Either you differentiate or you divide by x, right? Whatever method you can use. So I'm dividing by x because dividing by x would be simple over here. So divide by x. Divide by x. This becomes 1 minus 1 by x plus 1 by x square. This becomes plus a. Right. Now if I put x tending to infinity, this becomes 0. This becomes 0, this becomes 0. So in the numerator I'll get a minus 1, denominator I'll get 1 plus a. Now this value is equal to b and b needs to be finite. Now observe over here, a is plus minus 1. If I put a is equal to minus 1, 1 minus 1 becomes 0, then b would be once again not defined. So I know from here a can never be equal to minus 1, which implies that a is 1 only. And if a is 1, find out the value for b. b is minus half, right? तो अपने पास आंसर आ गया, a1 है और b माइनस हाफ है. फटाफट से यहाँ पे देखते हैं a1 और b माइनस हाफ कहाँ दिख रहा है. ऑप्शन नंबर b is the correct answer, right? So in case when you get infinite minus infinite, we have to simplify, we have to manipulate, because at the end it should turn down into 0 by 0 and infinity by infinity only. Once we have got the form of infinity by infinity, either you can directly use L'Hopital over here, right, in this particular expression, then also you will get the same answer. But I could see, right, but I was smart enough to observe, just like you guys, कि यार यहाँ पे अगर मैं L'Hopital लगाऊंगा तो गंदा हो जाएगा, right? Why not infinity by infinity में मैं x की मैक्सिमम पावर बाहर निकाल लूँ? बिकॉज infinity by infinity में दो ही अप्रोच है, या तो आप L'Hopital लगाओ या फिर आप x की मैक्सिमम पावर से ऊपर नीचे डिवाइड करा दो. अगर दोनों पावर्स ऊपर नीचे सेम होंगी तो आंसर आएगा अपने पास एक फाइनाइट, अगर ऊपर वाले की पावर ज़्यादा है तो आंसर इनफाइनाइट है, नीचे वाले की पावर ज़्यादा है तो आंसर 0 है। यही 3 पॉसिबिलिटीज़ बनती है अपने पास केसेस में, राइट। सो नाउ वी हैव डिस्कस दिस पर्टिकुलर क्वेश्चन, सो विल मूव ऑन टू द नेक्स्ट एग्जाम्पल नाउ, राइट। जस्ट स्टे विथ मी। Now let's see the next example, 2021 27 July, right? Shift 1 क्या बोल रहा है क्वेश्चन? ये बोल रहा है f goes from r to r such that f2 is 4, f dash 2 is 1, then I have to find the value of limit x tending to 2 something something something. So let us write the question first. So limit x tending to 2 x square f2 minus 4 fx upon x minus 2. Now see over here guys. First of all, we will put the value of x in the expression to find out what form it is. So if I put x is 2, I'll get this is 2 square, that is 4, 4 into f2 minus 4 into f2, this becomes 0. Denominator 2 minus 2 is 0. So I know this is 0 by 0 form and nothing else. If it's 0 by 0 form, then I will use the L'Hopital rule, we'll differentiate the numerator, we'll differentiate the denominator, और कुछ नहीं करना है बस. Right, we don't have to be a rocket scientist, just whenever you see 0 by 0, infinite by infinite, differentiate. Now f2 is a constant, right? f2 is what? एक function में आपने x की जगह 2 डाल दिया है तो x तो बचा ही नहीं ना वहाँ पे, तो f2 is a value or a constant, so the derivative of x square would be 2x into f2 minus 4 is a constant, derivative of fx would be f dash x, denominator of x minus 2, derivative would be 1, right? So now you put the value of x is equal to 2. So you'll get 4 f2 minus 4 f dash 2 upon 1. f2 value is given that this is 4, right? So this is 4 into 4 minus 4 into 1. So 16 minus 4, this is equal to 12. And I know my answer is option number D, right? So this is how we can solve, right, the questions on limits. And I have randomly picked the questions from years, right? 2021 and 2020 are the 2 years that I have focused upon, because उसके पीछे जाओगे तो हमको और simple questions मिलते हैं, and you guys are pretty much comfortable with them. 2021 is the recent time, so you also get to know the mindset of the examiner, what are they trying to ask, right? किस type के questions को पूछते हैं, क्या क्या चीज़ें कहाँ पे वो घुमाते हैं, right? So next example, right? फटाफट से इसको ट्राई करो, गिव मी अ मिनट, राइट? आई एम हियर ओनली, एक गिलास पानी पी लूँ बस। जब तक मैं पानी पीता हूँ, राइट, तुम सारे बच्चे लोग इस वाले क्वेश्चन को देखो एक बार, प्यारा क्वेश्चन है, थोड़ा सा डिफरेंट है, राइट? ट्राई करो इसको। हाँ भाई बच्चा लोग, right? So this particular question, if you see, you have a box over there, right? Limit n tending to infinity, box of r plus box of 2r and so on till box of nr upon n square. Remember my first trick? Whenever you see box, fractional parts, signum x and modulus x, we will always use, or we will always convert them, right? Or use left hand limit, right hand limit, whatsoever. Now in most of the books, right, or in most of the session that you'll see, people solve this by sandwich theorem. There is no need to solve this example by a sandwich theorem. We will just go by the simple basic. So I have a modulus, right? Those students who have studied from me, right, they know whenever you have a modulus, box, signum, try to remove them. So now in this particular example, I am using the completely purely concept, right, the basics of box and limits. So I have to find out this particular limit. So I have a box x, right? I have a limit n tending to infinity, numerator is infinity, denominator is infinity, it is infinity by infinity form, right? But I cannot do the L'Hopital, right? Because I cannot find the derivative of the box x, right? I can only find the derivative of the polynomials, not the box x. So now over here I'll convert this box into the algebra, right? Because if it's a algebra or a polynomial, then I can find out the answer. So box of r, I can write this as r minus fractional part of r. Yes or no, right? What I am using over here is x is nothing but box x plus fractional part of x, right? This is something that you have studied in the function topic. X is equal to box x plus fractional part of x. So I have replaced box r by r minus fractional part of r, plus this would be 2r minus fractional part of 2r, and so on, nr minus fractional part of nr, this upon n square, right? So अभी क्या करेंगे अपन, भाई भाई को एक साथ कर देंगे, मतलब पॉलिनोमियल्स को, और फ्रैक्शन पार्ट को एक साथ कर देंगे. So now I will have r plus 2r plus 3r and so on till nr minus r plus fractional part of 2r plus so on plus fractional part of nr upon n square, right? So now I can take r common from here, 1 plus 2 plus 3 till n. So I will have a sum of first n natural number given by n into n plus 1 by 2 minus, here I can't do anything, right? This is what the expression is. Now observe over here the second term, fractional part of r, no matter what r is, fractional part of r would be a fraction between 0 to 1, right? Fractional part of 2r, no matter what r is, 2r would be, no matter what it is, fractional part of 2r will always be 0 to 1, right? So it's a fraction, it's a fraction, it's a fraction, it's a fraction, fraction added n times, right? Now what is n? N is infinite. Now try to think logically. It's a fraction, right? Maximum value can be 1. So if I add 1 n times, in the numerator I'll get n. At max the value would be n, otherwise it would be smaller than n. In the denominator what do I have? N square, right? And n is a very large number. So square of a very large number is a super large number. So when I divide this value tends to go 0, right? Because denominator becomes very large as compared to your numerator, right? So this tends to 0. So now I am left with only this. This is polynomial upon polynomial, divide by n square, right? In the previous example also we have discussed polynomial upon polynomial, infinity upon infinity, divide by the maximum power. So if I divide this by n, this becomes 1, this becomes 1 by n, this becomes 2. Now you put n tending to infinity, this is going to 0. So I will have r by 2 as my answer, right? So I have converted the box as x minus fractional part of x, sum of all fractional part divided by n square, which is a very large number. This value will tends to 0, right? Hence the option is r square. So now we got the option is option number A. That is your correct answer. So now we move on to the next example. Next example, I have a limit going from x tending to 0, right? L is equal to what? Now see, in this particular example, I once again have box, mod and stuff like that, right? So shall I find out LHL and RHL, right? So if I find out the LHL and RHL, they are meant to be checked whether the limit exists or does not exist. Let's be slightly smart. Observe the options. Do I see limit does not exist? Do I see cannot be determined? Do I see none of these? No. I see 4 values over there, which means one of these answer is correct. So limit should exist. So I don't have to check LHL or RHL, but obviously to find out the answer, I will find out one of these values, LHL or RHL, right? Because both of them would be equal. So in this particular case, I will try to find out either the LHL or RHL, right? So we are more comfortable with the RHL. So I would be finding out the RHL over here, and whatever is the RHL is my answer. So RHL would be x tending to 0 means I will put a value slightly larger than 0. So a positive negligible amount, right? So 1 minus x plus mod x upon lambda minus x plus box x, right? That's it and nothing else. The next step will give me the answer. I don't have to do anything over here, right? So always remember, whenever you have such things, always remember LHL, RHL, right? Or remove these functions. If LHL, RHL will work only when you have options like limit does not exist, cannot be determined. Sometimes they also give you none of these. If 4 values are given, then I will find one of the limits. So 0 plus. So now put the value of x as 0.001, right? That is what we mean by 0 plus. So let me put limit x tending to 0 plus. So if I put 0 plus, this becomes x, right? Because for a positive value, mod x will be equal to x. So x minus x, this becomes 0. So I'll have a 1 over here. So my half of my question is already done. Lambda, I don't know what is lambda. Now minus x would be some x. Now box of x would be what? 0, right? Because if I take 0 point something, box would be 0. So this is 0. Now at the end, how much I have? Limit x tending to 0 plus 1 upon modulus of lambda minus 0 plus, right? So my answer is 1 upon lambda. Now what is lambda, right? Lambda is some value, lambda for some value, lambda belongs to this, L is equal to what? Now see, over here my answer is 1 by mod lambda, right? Now 1 by mod lambda would be the answer. L is equal to, lambda के बारे में हमें कुछ नहीं पता ना, for some value real, lambda is not a fraction, right? So see, lambda is not a fraction. Over here, look over here, lambda is not a fraction. If lambda is not a fraction, then I know 1 upon this value will always be larger than 1 or equal to 1, so larger than 1, right? If this is larger than 1, then the limit would be some fraction, right? So the fraction, I have only this. This will be 0 only when lambda becomes infinite. So lambda cannot be infinite, right? Lambda can tends to infinite but cannot be equal to infinite. So our answer would be 1 by 2. If 2 and 1 would have been the answer, then the lambda would have been either 1. If lambda becomes 1, then my answer would be 1. And if lambda becomes 1 by 2, then my answer would be 2, right? So over here in this particular example, the answer would be option number C. So now we can move on to the next example. Now, the next example belongs to 2020. Now, over here I would be using a property. So let us discuss the property first. Limit x tending to 0, e raised to power x minus 1 upon x. This is 1, right? So if it is e raised to power something minus 1 upon something, and if something is tending to 0, my answer would be 1. So now let's see what is the question. So limit x tending to 0, this is x into e raised to power 1 plus x square plus x ki power 4 minus 1 upon x minus 1 upon 1 plus x square plus x ki power 4 minus 1, right? This is what is given to me. Now if I put x is equal to 0 over here, this becomes 0, this becomes 0, 1 minus 1 upon 0, 0 by 0, so e raised to power 0 by 0 minus 1 upon, this is also 0. So at the end this is 0 by 0 form. This is e raised to power something minus 1, right? So I am using this formula. So for this I should have e raised to power something minus 1 upon something. So I should have this over here. So I'll divide this by x and I will multiply this by x. Now observe, this part is e raised to the power something minus 1 upon something. So I can say this is equal to 1. X and x will cancel out. I am left with nothing and my answer is 1, right? But over here I have assumed one thing. What is that one thing? Over here, remember this formula, this needs to be 0, right? So when x is tending to 0, I am getting a 0 by 0 form. So I don't know whether this limit would be 0 or not. If it is tending to 0, then my answer is correct. If it is not tending to 0, then my answer would be limit does not exist. Now if I see over here, I do have an option does not exist. So I need to find out this value and check whether the limit is 0 or not, right? So before I mark my answer, I will check limit x tending to 0 under root of 1 plus x square plus x raised to power 4 minus 1 upon x, right? And we'll pray the answer come down as 0. So now it is 0 by 0 form. I will differentiate directly. You can also rationalize. That would be a proper method to find out the answer for this particular question, but I am just using L'Hopital without wasting any more time. So derivative of root of something would be 1 upon 2 root of something into derivative of this, which is 2x plus 4x cube. Derivative of minus 1 is 0, derivative of 1 x is 1. Now I put x is equal to 0. If I put x is equal to 0, this becomes 0. If I put x is equal to 0, I'll get 2. Right? So the value of this limit is 0. So when x is tending to 0, this expression is going to 0. So it is e raised to power 0 minus 1 upon 0. So I can say this one is correct. Hence my answer would be 1. Where is 1? Equal to 1. Right? If in case this would not have been 0 or this would have been something else, right, then my answer would have been the does not exist. The next example, right, it's a very good example, and this example has been asked many times in PYQs, not just in 1 year, it has been asked many times. So how do we solve this? Once again, right, over here we will be using the property limit x tending to a, that is x raised to power n minus a raised to power n upon x minus a would be nothing but n into a raised to power n minus 1, right? If you want to solve with the property, if you don't want to solve with the property, L'Hopital is the best way, right? Now let us see over here. If I put x is equal to 1, this becomes 0. If I put 1, 1 plus 1 plus 1 plus 1 till 1 raised to power 1, so n minus n is 0. This is 0 by 0 form. So why should I go with the proper conventional method? I have L'Hopital, right? I can find out my answer. So I will differentiate this. Now find out the derivative of the numerator. 1 plus 2x plus 3x square and so on plus n x raised to power n minus 1. Derivative of n is 0 upon derivative of x is 1 and derivative of minus 1 is 0. Put x is equal to 1. What do we get over here? 1 plus 2 plus 3 and so on till n. This is my answer. This is nothing but n into n plus 1 by 2. Right? So this is equal to 180. Okay, so I have to find out n, right? So this is the value of the limit n into n plus 1 by 2. Now this is given as equal to 820. So I have equated it to 820. So from here I'll calculate n into n plus 1 is 820 into 2, right? Now there is no need to find out this quadratic. I know n would be sub integer. This is two consecutive natural numbers, right? Or two consecutive, natural numbers, right? Because it is given as natural number in the question, n belongs to n, right? So n into n plus 1 is product of two consecutive natural numbers. Try to factorize this and try to represent this as a product of two natural numbers. If we can, then we can save time. Otherwise, forming a quadratic and finding out the root is the last approach. So what is 82, right? It is 82, right? So 82, I can break this 10 into 2, then 82, this is 2 into 41. Yeah, cool, right? So we can see this is 40 into 41. So I can write this expression as 40 into 41. This is equal to n into n plus 1. So product of two consecutive natural number, n would be the smallest. Take the smallest one. Obviously 40 is the smallest. So your answer is 40 for this particular expression, right? So it's a numerical type. So your answer would be 40, which you can mark. Next question, x tending to 2, right? Now if you put x is 2, this becomes 9 plus 3 minus 12 upon 3 raised to power minus 1 minus 3 raised to power minus 1. So I can say this is equal to 0, this is equal to 0. So it is a 0 by 0 form, right? So if it's a 0 by 0 form, I will do nothing, right? I'll just differentiate the numerator and the denominator. So in short, the L'Hopital rule. So limit x tending to 2, derivative of 3 raised to power x is 3 raised to power x ln 3, 3 raised to power 3 minus x, the derivative would be 3 raised to power 3 minus x into ln 3 with a minus sign because I will have a minus sign over here. 12 becomes 0. This is equal to 3 raised to power minus x by 2 ln 3 minus divided by 2 minus 3 raised to power 1 minus x ln 3 and minus. right? So now ln 3 will cancel out and we are left with limit x tending to 2, 3 raised to power x minus 3 raised to power 3 minus x upon minus 3 raised to power minus x by 2 upon 2 plus 3 raised to power 1 minus x. Now if I put x is equal to 2, this becomes 3 square, this becomes 3 raised to power 1. So it's become 9 minus 3, right? So 9 minus 3 becomes 6. And this becomes 2 by 2 is 1, 3 raised to power minus 1 is 1 upon 3. So minus 1 upon 6. This is 1 upon 3. So this becomes 1 upon 6. So this becomes 36, right? So answer for this particular question would be 36. So whenever you see 0 by 0, infinity by infinity, all we have to do is nothing. Use the L'Hopital, differentiate the numerator and denominator. Next example, right? Now remember 1 raised to power infinity, I have told you that I will give you one more approach, right? So what is that approach? If you have limit x tending to a, fx raised to the power gx, right? Where limit x tending to a, fx will give you 1, limit x tending to a, gx is giving you infinity, right? So basically if you are having a 1 raised to power infinity form, the answer for this you can say it is e raised to the power limit x tending to a base minus 1 into power, right? So this will be your final answer. What is the answer? E raised to the power limit base minus 1 into power, right? So I just have to calculate this particular limit. Now observe over here. First I have to check whether it is 0 by 0 or not. So if I put x is equal to 0, I could see the power is infinity, right? If I put x is equal to 0, this becomes 0 plus 2 upon 0 plus 2, which is 2 by 2, which is 1. So hence I know this is going to 1 raised to power infinity form. So whenever you have a 1 raised to power infinity form, right, try to understand, because this is one of the एरिया जहाँ से क्वेश्चन आते हैं बहुत सारे, राइट? या तो 0 by 0 infinity by infinity पे आते हैं, या फिर तुम्हारे पास 1 raised to power infinity के क्वेश्चंस आते हैं. So now how will I solve? My answer would be e raised to the power limit x tending to 0 fx, that is your base minus 1. So base minus 1 into gx. So e raised to the power limit x tending to 0. Take the LCM. So you will have minus 4x square in the numerator upon 7x square plus 2 into I have 1 by x square, right? Oh good, I can see x square will cancel out. Now if you put x 0, this becomes minus 4, this becomes 2. So I have nothing but e raised to power minus 2. And this is my answer. So e raised to power minus 2 is nothing but 1 by e square. So now you can see option number C is 1 by e square, which is your correct answer for this example, right? So this is how we can solve 1 raised to power infinity. This is the one approach. The other approach is, as I said, take the log on the both side and then simplify. Next question, the value of the limit theta goes to 0. If theta goes to 0, cos 0 is 1. So this goes to pi. Tan pi is 0. Sine of 2 pi sine square theta. If theta goes to 0, this is 0. Sine of 0 is 0. This is tan 0 upon sine 0, which is 0 by 0. Hence, I have to, this is become 0 by 0 form. So either I can use the L'Hopital, right? So in L'Hopital, only thing I have to just observe is my derivative should not be lengthy, right? So I can differentiate this, right? So without using any logic, I am differentiating it directly. So what is the derivative of tan of something? Derivative of tan of something is sec square of something. Now the derivative of something, pi, cos square theta, derivative is 2 cos theta into sine theta minus sine theta, right? So I will have minus sign over here. This is the derivative of the numerator. Derivative of the denominator, sine of something is cos of something into something ka derivative 2 sine theta into cos theta, right? So pi gets out with pi, right? 2 sine theta cos theta, 2 sine theta cos theta. This gets out. Now if I put theta is 0, this is 0, so this is 1 pi sec square pi, right? Sec square pi would be 1, so this becomes minus 1. If I put theta is 0, this is 0, so cos 0 is 1. So my answer is minus 1, and unfortunately I don't see minus 1 among the options, right? So let us quickly see if we have not done any silly mistake. So tan of something is sec square of something, pi cos square theta, then pi into cos square theta, it is 2 cos theta into sin theta. I have a negative sign outside, wonderful, numerator is correct. Sine of something is cos of 2 pi sin square theta, that is correct, into 2 pi. Oh, I missed this 2, right? This is, I have a 2 over here. Yeah. So my answer is option number A. Right? So option number A is the correct answer for this particular example, right? So with that small hiccup, right, we were able to solve out this particular problem. So now we'll move on to the next example. So next example, I have a box over there, right? So x minus box x whole square, wonderful, right? And denominator I have x minus x cube, and देखो नसीब अच्छा है, 0 plus पे ही पूछ रहा है, right? So he is the examiner himself is asking us at 0 plus. So 0 plus मतलब 0 से हल्का सा बड़ा, 0.01 something something something, right? So let us first see, if I put 0 plus, what will be the box x? Box x will be exactly 0, not tending to 0. So this becomes a exact 0, this becomes a exact 0. They are not tending to 0. So exact 0, I can remove them, right? So they are constant. So this becomes cos inverse x into sin inverse x upon x into 1 minus x square, right? Denominator I have taken the x common, nothing else, right? Now sin inverse x by x, this is 1, right? X tending to 0 plus, cos inverse 0 plus would be pi by 2, right? Because you get cos value 0 at x is equal to pi by 2 only. So I get pi by 2 into 1 upon, if I put 0, this is 1. So my answer is pi by 2. Right? So a easy peasy question. It looks like difficult, right? It looks like scary. But if you know x goes from 0 plus, the box x will be exactly 0, right? So in limit, if there's a constant or exactly 0, I will write exactly 0. Why should I write 0 plus h, right? So with this, we have come to the end of this particular session on limits, where we talked about different things as far as in context to the limits, right? So before we finish up this particular session, let us talk about the Rapid Revision Rankers program, or known as RRR program. It is specially designed for the students who are preparing for IIT JEE 2022 attempt only. So in these classes are different from the master class. Master classes are for everybody, right? And the master class, we focus upon particular sub-concept. So every lecture you will find that there is a concept taken. Over here, these are the live classes that happens on our portal, right? In these live classes, we take up the topics, right? Every topic which is for your JEE Main and JEE Advanced. So every lecture will be based on some topic. So your top educators would be taking on those topics. Apart from those live classes where the teacher is teaching you, addition to this, you will always get a self-learn videos, which are the recorded videos where you can watch the concept, right? Every recorded lecture is available over there, and the live would always be there. Self-learn flashcards are for you to memorize things, right? So it is handy when you talk about the inorganic chemistry, right? The organic chemistry, the formulas of physics and maths. So flashcards are handy, especially metallurgy, P block, D block, right? Flashcards are super handy. Adaptive practice and the daily tests, other tests are also available, right? So if you are interested in this, want to know more about this particular program, then you can visit the website /JEE, right? So this is the link for this RRR. For masterclass, visit the website. For this YouTube sessions, right, like, subscribe, share. And we have a Telegram group where we share the assignments, right, or the notes for all the YouTube live session. So this is the Infinity Learn JEE. This is the link. Go on to the Telegram, type Infinity Learn JEE, right? Or if you want to have the link will also be given in the description of this particular session. So with this, guys, thank you so much for being here. Thank you so much for listening to me. I'm your host and host and your friend. So I will be here tomorrow once again at 2:30 p.m. with some other concepts and topics of mathematics which are required for JEE training. Till that time, enjoy your evening, enjoy your day, and keep practicing.